In this second question, we are asked to complete the table to show the number of unpaired electrons. So unpaired electrons, they even bolded for you. So make sure you know how to, write down electronic configurations. So we know that this is S1 and S2. SU are the S block element. If I just draw one orbital, because S orbital, you only have one orbital in the S subshell. So this is when you pair them up. So there is 0 unpaired electrons and there's 1 unpaired electrons. When you come to aluminium will have S2 P1, silicon is S2 P2. Well, basically it's 3 to be honest. Of course, there are some other bits before that, like the 1s2, 2s2, 2p6, but I'm just focusing on the important one. So there's 3p3, 3s2. Well, I'm sick and tired of writing the s. You can assume that the s is full now. So blah blah blah, and then 3p2, blah blah blah, 3p3, blah blah blah, 3p4, blah blah blah, 3p5. And now you have fully filled your p orbital. So 1, 2, 3, 4, 5, 6. This is the noble gases. Fully filled outer shell, including the fully filled s orbital, the 3s orbital. There is no unpaired electrons or whatnot. When it comes to aluminium, so if I just draw a partition here so that we are not confused. So I'm not drawing in terms of energy. I'm not saying that this is lower in energy than that. Be very careful, yeah? I just want a bit more space. So this is 3p1 because there's only 1 electrons in the p orbital, whereas this is 3p2, and then it's really a bad idea for me to keep on drawing it because you might interpret it as difference in energy. I'm just going to show you 1, 2, and 3 because when you come to p, this is group 15. Group 15 would have 3 electrons in the p orbital because this is very famous versus the group 16 where you have to pair them up like this, and this is your famous paired electrons repel more than unpaired electrons in your AS first ionization energy essay. So for this group 16p4, you only have 2 unpaired electrons there, and then for chlorine, you put 1 more there to pair them up. You only have 1 unpaired electrons for chlorine, and it decreases to no unpaired electrons at all when everything gets paired up for the noble gases. This is quite easy, 3 marks. You need to be careful to score the best you can if you want to do well for paper 4. Always read the questions, always think back on your AS chemistry. This next bit is also AS level chemistry. This is a reactions of 2 period trichlorides with water. So we know that SiCl4 reacts with water. There is hydrolysis. The same thing with PCl5. Okay, they're asking for observations. I'm just going to write an equation first. That will not be acceptable as an answer, but in order to think about what actually happened, I'm going to write an equation so that I can see what happened. You will see that there's plural there because of observations. So you cannot just write 1 observation because they're asking for plural, and for that 3 marks, better be safe than sorry, I guess. Probably not. Probably it's 1, and then somehow 1 mark there. Don't know. Maybe not. Gotta balance your equation, obviously. SiCl4 has 4 chlorines, so I'm putting in the 4 Cl there. 4 hydrogens, you need 2 H2O like that. When you have PCl5, when you add that with water, you'll know from a lot of my topical playlists involving these chlorides of period 3. This is phosphorus plus 5. When you get the acid, you're gonna get phosphoric 5 acid. Because you're not doing a redox reaction, you must still get phosphorus plus 5. There's PO4 3 minus, H plus because for the acid. So I don't mean oxide, I mean phosphoric 5 acid. So when you combine 1 and 3 of them, of course you know about how formula works. So you need 3 of that H plus and you need 1 of that PO4 3 minus. You are going to get H3PO4. But of course the equation is not balanced. The only way you can balance it is if you actually produce HCl as well. And also we have to get how many phosphorus? So phosphorus is fine, but we need 5 HCl. And having said that, we need 8 hydrogen, which is 4 H2O. That's how the 4 oxygen come from. And this equation is balanced. They're asking for observations rather than equations, so be very careful. You don't get marks for writing down equations, but by writing down equations, I can see SiO2 is insoluble in water. It's a component of white sand, so I get a white solid form. Or you can say white precipitate forms. You also get a steamy white film, as this reaction is very, very exothermic. You're just breaking covalent bonds. You're forming a lot more covalent bonds. You're forming a lot more covalent bond, therefore it is very exothermic. You get steamy white fume. What else can we say about the second one? You also get very exothermic reaction forming, so that is steamy white fumes. The thing is H3PO4 can dissolve in water to give you phosphoric 5 acid, and therefore you can say a colorless solution, but I mean PCl5 is a colorless liquid to begin with, so steamy white fume should probably be enough. In both of these cases, you're producing strong acid. Here you're producing 2 strong acid. Some of them can dissolve in water. Obviously, you're going to get pH2, pH1. Both of them are very strong acid. pH1 will be correct as well. pH2 will be okay. pH3 is probably a bit too high for such strong acid. They want you to write an equation for SiCl4 and H2O here. I already written the equation before, so I am just going to copy paste it into the space given there. Whatever you do, make sure you balance your equations. Do not write any equations without it being balanced. This is surprisingly low for these 7-mark questions in this A-level paper. But anyway, they can ask you anything from AS syllabus as well, so make sure you know your AS stuff.